about the first problem. So most of the coin problems I've given you have just been restricted to just 2 coins because when you have 2 variables and we only know how to solve 2 variables. This one's a little different because at first glance it's got pennies, nickels, and dimes. It looks like it's significantly harder, but once you write it out, it ends up being, I don't think it ends up being that bad. First, it says the wallet contains the same numbers of pennies, nickels, and dimes. So the number of coins is the same. So I know that my pennies, the number of pennies is going to equal the number of nickels, is going to equal the number of dimes. That's like one big equation. Now let's talk about the value equation. And my value equation is $1.44. So I see a penny's worth 1, so I could say 1p or just p, plus, let's see, a nickel's worth 5, so I have 5n, and a dime is worth 10, so I get plus 10d is equal to 144. So I have, these are kind of effectively my 2 equations. Well, if p is equal to n and d, that means everywhere I see an n I can plug a p, and everywhere I see a d I can plug a p. So what that means in this equation is you can change them all to p's. So this is going to give us p plus 5p plus 10p is equal to 144. I end up with 16p is equal to 144. And when I divide, I end up with p is equal to 9. Now on the forms, I ask, well, how many nickels do you have? Well, how many of each type of coin where they're all the same, so you end up with 9. All right, next question. We have a mixture problem. You have 6 liters of water that have 20% strawberry juice. How many liters of 80% strawberry juice should be added to the mixture to make a 75% strawberry juice solution? Probably finished all that. So mixture problems, and how you're going to set up your mixture problem, you make a chart. So as far as making a chart, you end up with, I have my 3 columns. I'll have my amount. I'm going to have my percentage. And I always have trouble naming this last column. I call it how much pure substance you have. And what's a little different, there was a problem like this on homework where normally you put an X here, a Y here, and a number here, but that's not what's happening. First, it says the 2 things that we're mixing go on top. So we're mixing a 20% solution and an 80% solution. And what you want, I guess I should call this 1 at the bottom, is we want a 75% solution. And once you get the percentages right, in the right spot, then you start, well, how much of the 20% do we have? Oh, well, we have 6 liters of the 20% solution. It's asking how many of the 80% solutions. I don't know that, so I'm going to call that an X. And I really don't even know how much of the mixture I have, so I'm going to call that a Y. Actually, what I should have done with percentages, I should have made these 0.2, 0.8, and 0.75. Now, to finish my chart, I'm going to multiply across. So this times this goes here. So that's going to give me 1.2. This times this goes here. So I get 0.8x. And this times this goes here. I get 0.75y. And actually, I should have been a little sarcastic. It says how many of an 80% solution has to be added to make sure we get 75%. And the answer, the smart aleck answer is a lot. Because if you've got something that's mostly water to get it to be mostly strawberry juice, you got to add a ton of stuff to it. So when we get our answer, you're going to see that answer ends up being a lot. Now, once you have the chart, you've got to get your 2 equations. And your 2 equations come from the first column and the last column. So our first column, this plus this equals this. So we end up with 6 plus x is equal to y. My second equation from this column is this plus this equals this. And so that gives me 0.75. Here, I'll write it. 1.2 plus 0.8x is equal to 0.75y. All right. Now, this looks like this right now. This is screaming substitution, meaning I'm going to take I'm going to replace whatever y is, I'm going to plug that in here, so I end up with 1.2 plus 0.8x is equal to 0.75 times 6 plus x, and now I solve. So to solve, I end up with 1.2 plus 0.8x equals, when I distribute, I'm going to get 4.5 plus 0.75x. This is, if I subtract this, I get 0.05x is equal to, and I subtract that, I get 3.3. And it turns out x ends up being 66 liters. So that's our answer, 66 liters, which if you compare 6 liters of water, you got to add a ton of something that's mostly strawberry juice so that you can end up with a 75%. All right, so that's one thing. Now, what I'd like to do, sort of open this class up to questions. I've got to teach one thing today, and that one thing is rate problems, and they're easy rate problems and hard rate problems. We're just going to focus on the easier ones today. But let's make sure we know how to do digit problems. Okay, right now, if you struggled, right, I will post the answers in OneNote. Right? Are there any of, let's see, the first half, so 2 through 10, that you want to see set up? The solutions will be in OneNote. So right now is your chance to ask. All right, I'll go ahead and kill the suspense. One of your 4 problems will be a digit problem. One of your 4 problems will be a rate problem. So I'm teaching that today, and we'll answer questions tomorrow. Right? You'll probably have a coin problem. Right? You'll probably have a mixture problem. I mean, if you think about what I've sort of stressed the past few days, So, all right. Any questions on the first?
Can we do 12?
Yes, we can do 12. I'll set anything before 12.
Can you do 4?
Okay.